Hello everyone and welcome. In this lesson we're going to be finding the domain and range of functions. The domain of a function is the set of all input values, and the range is the set of all output values. Here we have a function represented in the form of a table, and our input values are listed on the left side of our table, the output values on the right. So we would say the domain of this function is the list of numbers on the left, -1, 0, 1, 2, and 3, and the range is all the outputs we can get, -5, 0, 5, 10, and 15. Now, if we change our function a little bit and have the same inputs, then our domain is going to be the same. But if all we have is one single output, then our range is just going to be one single value. Here we have a line segment represented on a coordinate plane. And when we're dealing with a graph as a way to represent a function, we look along the x-axis to represent the inputs, and along the y-axis, up and down, to represent the outputs. Now you might say the furthest to the left that this graph can go is -2. So the furthest we can go on to the left on our x-axis is -2. And the furthest to the right we can go is 2. So therefore the furthest to the right on the x-axis we can go. And because we're dealing with a line segment, we're going to reach every value between -2 and 2 on the x-axis. So therefore our domain is going to be every value between -2 and 2. Now, we're no longer dealing with a simple list of numbers. We're dealing with an infinite number of values. Like I could say 0, 0.1, 0.2, 0.3, a tenth, 2/10, 3/10, so on and so forth. And that list is going to be so long, it's going to take forever to write it. So to represent those values, we just sort of think about it as a start point and an end point. So the furthest to the left we're going is -2. Furthest to the right is +2. We're reaching every value between that, and to show that I'm reaching every value in between there, I'm going to use square brackets to represent the list. Same thing with the range, but now I'm looking along the y-axis. The lowest I can go is -1, the highest I can get is +3, and I'm going to achieve every value between -1 and 3, so therefore the range is -1 to 3. And once again, we have the square bracket notation, and one way that we can think about it is sort of a start value and an end value, and the square brackets tell us that we achieve every value between those two numbers. Here we have a domain of -2 all the way to 3, and a range of -4 all the way up to 5. Here we have something a little bit more complex, but the same sort of strategy can be shown here. How far to the left do we go? How far to the right? How low can we go? How high can we get? All right, here, let's switch things up a bit. Here we have an empty circle, or a hollow circle, if you will. This tells us that our line segment gets closer and closer and closer to 2, 3, but never actually reaches that value. It gets really, really close, but never actually ever touches 2, 3. So to show that we start at -2 and get really close to 2, but never touch it, I switch my square bracket to a parenthesis. This tells me I will reach -2, but I won't go all the way to +2. And the same thing with my range. The lowest I can get is -1, and I will reach that, which is why I have a square bracket there. But the highest I can get is really, really close to 3, and because I will never actually reach it, I want a parenthesis there to designate that it's never actually going to be part of the range or 2 as part of the domain. The furthest to the left I can go is -4, but because that's a hollow point, I never actually will achieve it, and the furthest to the right I can go is 2. So once again, I'm going to use parentheses on both sides here to show that I never actually reach the furthest endpoints on the left and the right. Same thing with the range. The lowest I can go is -4, and I never actually reach that, but the highest I get in this case is 3, and because we have a shaded circle there, that tells me I will reach it, so therefore 3 is in fact part of my range, and we can use a square bracket to show us that 3 is included in the range. Here we have an arrow, which tells us that if we continue along the line segment, we're actually dealing with a ray, which is going to get further and further and further, never stopping, going all the way to infinity. So the furthest to the left I can go is -2, and the arrow tells me I'm going to continue right again and again and again and again, further and further and further, and we can never actually get to infinity. We go to infinity and beyond. So to show that I can never actually reach infinity, we use a parenthesis whenever we're dealing with infinity. Same thing with the range. The lowest I can get is -1, and because the arrow continues to go up, the furthest up I can go is infinity, and I use a parenthesis to designate that it will never actually reach infinity. Here we have the opposite problem. The furthest to the left I can go is negative infinity. It's going to continue to go to the left. And the furthest to the right I can go is 4. The lowest I can go is negative infinity. It's going to keep going down. The highest I can get is 3. Here we have arrows on both sides, so we're going to go negative infinity to infinity, and this is actually a typo. The lowest I can get is negative 2. I apologize for that. The highest I can get is infinity. So this is actually supposed to be a square bracket with negative 2 and going all the way up to infinity. Here we have a function, and because the function is being cut off on the top, it might seem as though this curve, this red curve that we're seeing, actually stops, but we have to assume that the picture we're given is just being cut off and actually continues on to infinity. So the furthest to the left, because it keeps going to the left, is going to be negative infinity. The furthest to the right keeps going wider and wider to the right. Our domain is going to be negative infinity to infinity. In the range, the lowest I can get is negative 2. This one is correct. I have a square bracket there, and it goes all the way up to positive infinity. So I have a parenthesis next to positive infinity. The opposite is also true. Here, the graph continues to get wider and wider, so our domain is going to go off to negative infinity and infinity on either side. In the range, we're going to go all the way down to negative infinity, and the highest we can get is 3. Here I have a function that seems to start at the origin. So we're going to say the furthest to the left I can be is 0, and it seems to reach that value, so I'm going to put a square bracket there. It goes off to the right towards infinity. The lowest we can go is 0. The highest we can get is positive infinity, so that's our range. Here we just have a line similar to the second example we saw. The domain is everything to the left and everything to the right, but the range is just 2. That's the only output we're going to ever see. Regardless of whatever our input is, the output is always going to be 2. So we can just go ahead and say the range is 2. Here we have a function, and it's hard to see and it takes experience, but it actually doesn't go lower than 0, and it will actually never touch 0. So the range is going to be everything up to 0, not including 0. That's why we're using a parenthesis, off to infinity, but the domain is everything to the left, everything to the right. And we'll go into greater depth about more complex graphs like this sooner, knowing how we know that it's closer to 0 but never actually touches that, and so on and so forth. We'll go into deeper later in the course. Here we have something that goes off to infinity on either end. So goes all the way to negative infinity on the right, all the way to positive infinity on the right, drops all the way to negative infinity, all the way to positive infinity. And thank you. I know that was a lot, but I felt as though more examples were going to help clarify a lot of the complex nuances there are when we're finding domain and range. So I hope this video was very helpful and that you visit us again.